Okay, so this is a continuation from the previous question, but now we have the added effect that there is friction. So if I redraw this picture again, so again we have, there's our block. It's on some surface. We're pulling upwards with some force at 30 degrees. That's 40.0 newtons. We know force of gravity, Fg. Well, we saw that last night as 98.1 newtons of force. We have normal force, Fn, is equal to 78.1 newtons. And there's also this force of friction now. Force of friction. So when solving this one, well, let's create our equation again. So we say sum of the force in the F net in the x direction is equal to mass times acceleration in the x direction. That's going to be that F applied x value, FAX, applied in the x direction, minus that force of friction. Okay. So in the previous one we saw force of friction was 0. So what we know for force of friction is equal to the coefficient of friction times our normal force. This is where we have to be careful. In the previous ones, we always said that normal force is equal to force of gravity. We cannot always assume that. So we have to look at the sum of the forces in the y direction. So we actually already did that, but I'm going to show you again. So again, if I look at the y direction, we have F net in the y direction is equal to MAY. There's no acceleration in the y direction, but we saw that there's normal forces up, and there's that F applied force in the y direction, and there's force of gravity. So when we solved for this equation right here, we solved for the fact that our normal force was actually 78.1 newtons. So it wasn't actually just equal to force of gravity. Normal force ended up being the force of gravity minus our applied force in the y direction. So when we plug into this equation right here, we have F net x is equal to mass times acceleration in the x direction. Our applied force, we found that to be, what was that again? That was 40 multiplied by cos 30. I'll write it out. So we have 40.0 newtons multiplied by cos 30 to find the x component of our applied force, minus our coefficient of friction times our normal force. So we get 10.0 kilograms times our acceleration in the x direction. This came out to be 34.6 newtons. Our coefficient of friction is 0.200, and we found our normal force to be 78.1 newtons. So 34.6, 4101615 minus 0.2 times 78.1. We have a net force of 19 newtons. Divide that by 10 kilograms. So with this friction, our acceleration is less, which makes sense. We get 1.90 meters per second squared.